So let's do the formula. I'm just going to give you the formula and then we'll try to explain why it's true. The probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. So why does that work out? Let's look at an A and a B. I'm going to draw this with A shaded yellow and B shaded blue. So the probability of A, and I'm going to try to draw that, although it can be hard to draw parts of a circle. So hopefully this gets across the idea that this is part of the probability of A plus the green part. It looks like a little fish with no tail. Then you also have the probability of B, which is this fish with no tail and this blue part circle. And if I look at what the probability of A or B should be, it's the yellow plus the green plus the blue, because between these three pieces, we get everything. So if I have the probability of A or B, I would be looking at the part here that is A but not B, plus this part in the middle that is A and B, plus this part on the right here that is just in B and not in A. So this is a visual representation of what each of these how you can see each of these probabilities in the Venn diagram. And this is intended to illustrate why you need this important term. And this is a term people often forget. You need to subtract off the overlap. Otherwise, you overcount. If I just added probability of A plus probability of B, so if I were just to add the probability of A plus the probability of B, I would end up with all of this. And you notice that what happens here is that the probability of A and B gets counted twice. This cap symbol we'll talk about is A and B. So the probability of A and B is showing up twice, but I only want it to show up once. So by subtracting off the probability of A and B, if I take this picture I had before and I subtract off the extra A and B so that they cancel out, what I'm left with is what I wanted, which was the probability of this A or B, A union B, put together. So in words, we could try to explain it this way. Both A and B contain the things in the set A and B. And we'll see later, that's also called A intersect B. If we just add the probability of A plus the probability of B, it overcounts by counting twice the things that appear in both sets. So that's why when you have the formula, it's extremely important to subtract off the probability of A and B so you don't overcount. Now there's a special case of this where it's simpler, but the simple special case only works if you're completely certain that you meet the conditions to apply it. Let's talk about that simpler special case. So if A and B are disjoint, that means they have nothing in common. Then the probability of A or B is just equal to the probability of A plus the probability of B. But notice, this formula that I gave originally, we call the additive rule or the general additive rule, this always works. Whereas this special case is only true if this condition is met. So in order to not subtract off the overlap, you have to make sure the events are disjoint. So here's a visual representation of saying disjoint events have no outcomes in common. Disjoint events here don't overlap at all. These two events, C and D, are not disjoint. They have something that is in both C and D. So we've seen two formulas. We've seen a general addition formula that always works. We've seen a special addition formula that only works if we know the two events are disjoint. And so now let's do some problems that allow us to practice with this.